In this type of improper integral, there is a discontinuity on the lower limit. Look at the graph I prepare for you. I am looking for the integral of f of x dx. X goes from a to b. However, in the lower limit a, the x equals to a itself is a vertical asymptote. So to set up the improper integral, I am going to take a value t that is very close to a. So the value of t is on the right hand side of a. So I'm going to let t approaches to a from the right hand side. So the definite integral will be the integral from t to b. And then the area is right there. So that is the area under the curve of f of x. X goes from t to b. And then I'm going to take the value t that is so close to a and t approaches to a from the right hand side. Okay, so on the right hand side of the notes, I prepared 3 integrals for you, and then each of the integral there is a discontinuity. So for example, the first one, 1 over x, I know that x cannot be equal to 0. And then the next one in the denominator, x cannot be equal to -2. And then on the third one, there is no denominator. However, ln 0 is undefined. So the discontinuity of x times ln x is x equals to 0. So let's start from the first one. So I have integral from 0 to 1, 1 over x dx. So since the discontinuity is x equals to 0, I'm going to set up the limit. So limit as t approaches to 0 from the right. And then I have integral from t to 1, 1 over x dx. In case you're wondering why is that from the right, not from the left. So here is why. So suppose you have a number line. So this is a 0 and then this is a 1, and then on 0 there is a discontinuity, right? The discontinuity is a vertical asymptote, and then you will just take a number right next to 0, so right there, and then that is t, and then you let t approaches to 0 from the right hand side. So this number is on the right hand side of the 0, that's why t approaches to 0 from the right. The little plus symbol means from the right. If you use a minus, that means from the left. All right, so the integral of 1 over x is equals to ln. So we have that equals to limit as t approaches to 0 from the right. So we have ln absolute value of x, and then x goes from where to where? X goes from t to 1, and then you plug in the 1, subtract, plug in the t, and then you evaluate the limit. So we have limit as t approaches to 0 from the right. We have ln 1, so 1 is positive, then we don't need the absolute value anymore. And then ln t, right? So t, do we need the absolute value? The answer is no, because 0 on the right hand side is a positive value. So therefore, we do not need the absolute value. So ln1 is equals to 0. What about ln t? T approaches to 0 from the right. So this one, look at the graph. Whenever you have a hard time to decide what that equals to, look at the graph. So here is the graph of ln. We have the x-axis, the y-axis. There is one x-intercept at 1, 0. So x is equals to 1, y is equals to 0. And then this is goes all the way to infinity. That approaches to the other side, approaches to the y-axis. So on the y-axis, what is the vertical asymptote? We have x equals to 0 as the vertical asymptote. I call that a VA. So as x approaches to 0 from the right, so that means we are approaching 0 from this direction. Look at the yellow dot. So I am right here, right? I am approaching to 0 from the right hand side. So what happened to y? Y goes all the way down. So therefore, y approaches to negative infinity. So we have ln1 is equals to 0 minus this is negative infinity minus minus, that gives me a plus. So plus infinity. So therefore, we have an infinite area. So infinite. And then therefore, the integral is divergent. All right, so that's the first one. Let's move on to the next one. So look all the way up. You have the integral from -2 to 14, 1 divided by the 4th root of x plus 2. And then you can see that x, when x is equals to -2, we have a discontinuity, and the -2 is my lower limit. So let's switch to another color for the next one. We have integral from -2 to 14. And then 1 divided by the 4th root of x plus 2, and then dx. So here is the number line. So we have a number line right here. I want to keep the line straight, and then -2 to 14. So this -2 is a vertical asymptote, V8, V for vertical, A for asymptote, and then I have to take a number, t, on the right hand side of 2. So that's why t approaches to -2 from the right. Did I say of 2? The right hand side of -2, therefore t approaches to -2 from the right. And then you set up your limit, so that is equals to, please start with a new line with an equal sign, and then the limit. So we have limit as t approaches to -2 from the right. We have t to 14, 1 divided by the 4th root of x plus 2 dx, and then this is a u substitution, so we let u equals to x plus 2, and then du is equals to dx, so you have a u in the denominator. And then we have limit as t approaches to -2 from the right. We have 1 divided by, so basically it's 1 divided by the 4th root of u, right? So 1 divided by the 4th root of u, what is that equal to? I will just draw another limit for you. So t approaches to -2, so that will be the integral, right? So that will be the integral of u to the -1/4 du. This one, where is the lower limit and where is the upper limit? You can do this. U of 14, that equals to 14 plus 2, and then u of t, that is equals to t plus 2. But I don't recommend you to do this, so this part, let's just forget it. Just don't write the upper and lower limit. Just don't, skip that one for now. And then we integrate. T approaches to -2 from the right, so -1/4, you add 4 to it, that is 3/4, and then the reciprocal is 4/3, and then such that x goes from where to where? X goes from t to 14. And then this one, I know I have x equals to t to 14, but you have the u in there. So this one, it is okay to replace the u with the x. So we put the x back. This is a x plus 2. And then you do the fundamental theorem of calculus, FTC. So plug in. We have limit as t approaches to -2 from the right. We have 4/3. And then 3/4 plus 2, right? So we have 3/4 plus 2. And then, oh, not 3/4 plus 2. Why do I say 3/4 plus 2? 14 plus 2, huh? 14 plus 2. And then raised to, now we write the 3/4. And then minus the t plus 2, so 4/3, and then we have a t plus 2, and then 3/4. Okay, so this is, we have a 16, right? So we have a 16, and then 3/4, so that is the 4th root of 16, and then raised to the 3rd power, so we know that 2 times 2 times 2 times 2, that is equals to 16. So this is 2 to the 3rd power, and then that is equals to 9, right? Sorry, that is equals to 8. So we have 4/3 times 8, and then minus t approaches to -2 from the right. Okay, so 4/3. So how about this? How about this one? -2 from the right, plus 2, and then 3/4. What is that equal to? This one is 32/3, right? So 32/3. How about the other one? Is the other one equals to 0? What is 2 plus? 2 plus is right here. So we have a -2, and then a -2 plus, so it's a little bit greater than -2. So if you take that number, plus 2, what is that equal to? If you have a -2 plus 2, you get exactly equals to 0, right? So -2 plus 2, you get 0 exactly, right? And then what happens if you have a -2 a little bit more plus 2? So that means you have a little bit greater than 0. And then if you have 0 plus, and then you have 3 over 4, so that is just equals to 0. So therefore, you have a 4 over 3 times 0. So overall, that is equals to 32 divided by 3. Oh, and then thinking like this is what you have to do. So drawing picture and think like this. This is what you have to do in improper integral. You didn't do that in the other section, and this is what you have to do in improper integral. You have you learn this experience from the limit, right? So now you have to do this again in integration. So 32 over 3, the area is finite, so we have a finite area. So therefore, the integral is convergent. So that's the second integral I gave you. And then I have one more. That one is ln, right? So let's do the ln. So let me switch to another color. So we have integral from 0 to 1, and then x times ln x dx. And then we know that ln 0 is undefined. Because look at the graph of ln, when x is equals to 0, there is a vertical asymptote. So this is the graph of ln. So y-axis, x-axis, we have the graph that looks like this. When x is equals to 0, there is a vertical asymptote. So that's why 0 is a discontinuity. So we have from 0 to 1, so this is 0, this is a 1, so 0 is a vertical asymptote. Then we have to take a number t that is on the right hand side of 0, so t approaches to 0 from the right. And then the limit is t approaches to 0 from the right. We have 0 to 1, not 0 to 1, t to 1, and then x times ln x dx. And then this is an integration by parts. So by parts, and then we let u equals to ln x, and then du is equals to 1 over x dx. How come you don't let u equals to x? So when you do the du, you have a dx. The reason is, I said this when we were doing integration by parts. What I said was, the integral of ln, you don't know what that equals to. So that's why don't take the integral of ln. So dv is equals to x dx, integrate both sides. So you have the integral of x dx that is equals to 1/2 x squared. And then you do the uv minus the integral of v du. So you have a limit t approaches to 0 from the right. So uv, that is x squared over 2, and then ln x, such that x goes from t to 1, and then minus the integral of v du. Don't forget about the limit. The integral of v du, so the integral of v du, so that is 1/2 x squared, that is the v, and then the du is 1 over x dx. And then from where to where? From t to 1. Okay, FTC. Plug in the 1, right? So we have 1 divided by 2, ln 1, and then plug in the t squared to ln t. Okay, what about the integrations? Let's put this in a square bracket. So this one, you have the integral of what? The integral of 1/2 x dx, right? So you integrate that, so that would be x squared. So that would be x squared, and then you have a 1/2 times 1/2. So the 1/2 goes straight back here, and this 1/2 is the other 1/2 is came from the integration, because when you take derivative of that, you bring the 2 down. The 2 needs to be cancelled with the 1/2. And then you have a limit as t approaches to 0 from the right, and then the integration is done. So this one is from t to 1. So ln1 is equals to 0, so the entire thing is equals to 0. What about the 0 plus? So this one. What about this? This will be a 0 plus, so something a little bit greater than 0. You square that, that is equals to 0, and then ln 0 plus. And then this, what do we have? We have a 1 over 4 times 1 square minus 1 over 4, and then 0 plus square. This is interesting. So what is 0 plus equals to? 0 plus square. So think about this. 0.01 is a little bit greater than 0, you square that, you get something that is close to 0. All right, so how about ln 0 plus? ln 0 plus, you look at the graph. Again, when you do improper integral and then you are considering the plus and the minus, look at the graphs. So this is a 0 plus is right here, right? So that is goes all the way to negative infinity. The corresponding y value goes all the way down to negative infinity. So therefore, in here, I have a 0 and then multiply a negative infinity. So this is just a 0. You have 0 multiply negative infinity. So the whole thing is equals to 0. And then we have a minus 1 over 4, right? So minus 1 over 4, and then the other one, you square the 0 plus, that is equals to 0 as well. So this is a minus 0. So overall, you have a negative 1 over 4. So since the area is finite, so we have finite area, that means the integral is convergent. Alright, that is the end of this video. If you think my instruction is clear and helpful, give me a like, share the video for me, subscribe to my channel. See you all in the next one. Signing off for now.